Hey guys, it's Data Developer, and tonight I'm going to be benchmarking PhotoScan for AMD Ryzen Threadripper 1950X. The goal of this video is to show you that how fast it is for Ryzen to process images and reconstruct those images into point clouds, then into a 3D model that has all the textures and detail. So hang tight and we'll be talking about it or navigating about it soon. Okay, so what is PhotoScan? PhotoScan essentially is an app, a program that converts the images that is put into memory, into the GPU memory, or to the to RAM. Then it calculates the points that crosses between two sequential image or serial image. Those images, by the way, are numbered, so the PhotoScan know what's the sequence of the images, and try to extrapolate the color info or the markings so that you could convert the pixels, markings, or color info into vertices in 3D space. Once you have a very dense points, you can basically convert the dense points into a geometry that would represent the image in 3D. With that geometry, with those dense points, you can bake the color info taken from the picture, the sequence of pictures, into the 3D model that PhotoScan did, and it would look exactly or nearly as exact what the real what do you call that? What the real subject is. So let me see. To do that, we need to download PhotoScan, and I basically purchased this version of PhotoScan, which is $56.05. I mean, I'm not going to be making money off of this model. I'm just going to show how fast it is and how fast AMD Ryzen Threadripper CPU converts these photos into 3D models. And there are several softwares that can do that, but PhotoScan is the only software as of now that converts it and utilizes the power of CPU and GPU. Unfortunately, I couldn't get the GPU card working on my system, so this video only benchmarks PhotoScan with my AMD Threadripper CPU. By the way, I have two Ryzen, no, not Ryzen, but R9 390 8GB GPU from Asus. I think it will be fast if I utilize OpenCL with those two video cards, but like I said, it won't. I was not successful on making it work. Now, the data set that I'm going to be using, or photo set, would be this Cherub, the Cupid statue, and the man model. I've downloaded the files already, so Let me show you what it looks like. So the Cherub is basically very simple very simple scan of the image. You can utilize a video with photo scan, but I have not done it yet, using a video to as my data set to convert the video to a 3D image. But you can, if you're not using PhotoScan, which I think is the only one who utilizes, has the feature that utilizes videos, you can use QuickTime. Let me see. QuickTime and to image sequence. Yeah, basically in QuickTime, once you've loaded the video file that you captured from your camera or smartphone, you can export the image as sequence, and from there you could export the image. You can import the image into PhotoScan and process it to get the 3D model. So without further ado, let's start building 3D models. Now let me launch terminal. So I'm gonna CD to desktop, PhotoScan, and I gotta launch PhotoScan.sh. Alright. Oh, by the way, the second folder that I have is basically the body set, and the body set doesn't take the full view of the person. It has several weird what do you call that, weird takes of the non-proportional takes of the subject, in this case the male model, but with PhotoScan it still converts these images right here nicely into a 3D model. So let's dive into the Cherub scan. Okay, to do that we gotta create a new chunk. From that chunk we gotta add photos, and let me navigate to 3D scan, 3DFlow here. Okay, this data set, and let me select all those JPEGs. As you can see, they are numbered. That means they have a sequence from 1 to 65. That's 65 files. So, and each file is about 7.8 megabytes. So let's import it and see how fast it is. Oh, wow, that's fast. Consoles. Okay, so it took about 0.01602 seconds, which is fast. So now let's process it and align the photos. I'm going to set it to high and use a generic pre-selection feature. Key point limits, type point. Unfortunately, I don't know what they are, but I'm gonna set it to a default value for now. So let's hit OK and see how fast it is to process those images. 30 seconds left. Elapsed time is 5, 7, 8, 9, 10, 12, 13, 14, 15. And it's about 60%. I wonder if we could cross that 30-second elapsed time limit. Almost there, but yep, it did. Now 14 seconds left. So can we hit 14 or less than 14 with it? Apparently, come on. Yes! Now we have 54 seconds. Can we hit 54? I think we can. Oh my god. Yeah. Threadripper can rip through these processes fast with their fast new CPU design. They started from scratch and now they have this non-modular true multi-threading CPU design that is 16 cores able to multi-thread twice each core, so giving you a 32 thread advantage with that 16 core CPU. So can we beat, oh no, I'll do the next, I'll measure the next benchmark if it's finished. 17, whoa, that's fast. Wow, about 2 minutes for that processing in 2 minutes. Wow, that's not bad. So as you can see, these are all this is the dense points that I was talking. These are the sparse points, which is not dense yet, but basically it defines the very common very common extrapolated points from the images. Right now I'm gonna remove the photos and let's clean this up. To clean this up, I'm gonna zoom out with my middle mouse button and select the unwanted vertices. So select that. Oops. Select that. Select that. Select them. Select those. And delete it. Just press delete, I guess. And now I'm gonna navigate with my left mouse button, navigating with this arc ball navigator, and delete some floor vertices from the floor. Go to selection tool and select all these vertices on the floor. So, oops. Okay. Pan with middle click button and select with control mouse. Control first primary button, then navigate. Whoops. Gotta control. Oh, I can't control Z. I gotta do it again. I guess after this I can't select all the vertices yet, so I'm gonna delete it. Ooh. Oh, I control Z. Ah, that's not good. Let me see. Let's do the selection again. It's just simple. This is the problem with doing live demos. And it's 4 AM in my area. I've been sleeping like hell for the past few days. So bear with me, and I'll make sure you get all the info and benchmark you want to know benchmark results, you want to know if you're purchasing a new desktop. She'll delete it. Desktop CPU. Delete that one and delete this. Oops. Now I'm going to rotate the view. All right. Looks clean. And from this we could make a I could make a 3D model from this one, but let's look at how fast it is to process a dense cloud version of that points. It's going to produce more points and in a much higher resolution. So I'm going to use default settings. Set OK. 409 is the start. Alright. That first run was not really good. And wow, 2 days, 20 hours. Oh my god, we're gonna be here for a while. But anyways, let's see if it'll be accelerated soon. Let me show you the activity monitor to see how much CPU utilization we're doing. Boy. Nope. Unfortunately, my system monitor is not working, but because I'm using a custom kernel. Let me see. AR. Yep, it's a custom Threadripper kernel that I installed from when I made the video from the previous video. So please bear with me. And oh, now it's 2 hours, so it's not gonna take a while. So I hope you bear with me. 2 hours. Let me see. Oops, I think I did it wrong. Let's hit the medium settings to see how fast it really is. Because right now it's taking a while to process the tiles. Right? Cancel. Yes. Ported by user. Hi. Let's go to medium. There you go. Come on, go down 4 hours. Go down even more. Okay. It's weird. It's only doing a sequential build. Let's pause this one. Let's cancel this, yes. And look at the settings. So right now, GPU, use CPU in performing GPU accelerated processing. Nope. Appearance, navigation. Keep key points, def webs, enable. Tweaks. Nope. Navigation, appearance. Okay. Man, that would be cool if this program has a flag to use all the CPUs when you run the program command from the terminal, right? But for some reason, it doesn't let me use all the available CPU. So it's doing it sequentially. Now we go here. Oh, let's optimize the camera. Oh, that was fast. Now let's process the dense cloud. That is really weird why it's not calculating or processing the image in one single swoop, processing multiple images in one swoop. Okay, cancel. Yes. Now tool type points, go point cloud. Cameras, right? Let me see. Oops. Have to do multi-threading with photo scan. Okay, apparently he's not being friendly, so I'm gonna get a CPU monitor so that we can see if it's utilizing all the threads. But what's a good one? Let me Google it. What is a good CPU speed and thread monitor? Ubuntu. Wow! This Ask Ubuntu from Stack Overflow is really helpful. Nope, apparently there's no graphical interface for that one. CPU. Okay, now ladies and gents. Oh, let's try it again. and see if it works. Wow, so many. There's a lot of ads here. What is wrong with my installation right now? Nope, that's not the one I want. CPU's 32, okay. And apparently didn't system system monitor sudo okay, let's search that error because I did use a custom kernel. Nope, that's not the one. Huh, that is weird. Oh boy. I wonder if it's better if I install or use the default kernel for Ubuntu 18.04. Because right now it's not doing what I want it to do. Okay, yep. Wow, this is a fast fail video, so let me process this photo and show you how long it'll take if I use the default setting for the dense cloud build. So medium, yeah. And calculate all points, yep. So it will spit out the finished processing time there. So let me pause the video and let me hit OK and pause the video. I'll be back when it's finished and you'll see the result. Okay guys, we're back. And apparently it's finished. The dense reconstruction of the Cherub photo dataset that I downloaded from 3DFlow has been constructed. So now we're gonna build oh yeah, let's look at how long it took. So finished processing in 1654.19 seconds. Let's calculate that one. Okay, 16 divided by, by 1654 divided by 60. Is it eval? Nope, apparently not. Oh, yeah, why not that one? The calculator doesn't launch. Calculator. Wow, what apps doesn't work with this Buildalytics? Let me see. 16. Whoa. 1654 divided by 60. That's about 27 minutes. Yeah. 1,654 seconds. It's about 27 minutes. 1,200 seconds is 20 minutes. In 1654 it would be 27 minutes. So took about 28 minutes max. Ceiling if you want, but okay. Let's try to construct or build the mesh, the actual 3D model. Arbitrary dense value, yep, we don't want the sparse value. High, and calculate the vertex color. Now, elapse, oh, it doesn't show 2 minutes. Let's see if it'll finish in 2:47. 2 minutes and 47 seconds. Apparently it's fluctuating. It went up to 3 minutes, but now it went back down to 2 minutes and 37. Wow. Now it went down to 1 minute and 30 seconds. When I'm doing that, let me see what apps are not working. VNC works, Ubuntu Store, Kazam, Remima works. All these except these two right here doesn't work. So let me pick and choose mine. Games, yeah, it works. Okay. Power statistics, yeah. An app similar to this one should be important. Oh, it's not the statistical apps that that I thought about, but it's a hardware app. Because that works. Oh yeah, Office should work too. Oh my god, it's loading fast when it's initializing. And 1 minute has elapsed. We have 17 seconds left. Can we hit below 2 minutes and 24 seconds or 47 seconds? I can't remember. Nope. Okay. Almost all the apps except the calculator. The video app works too. And the calculator app. Nope. I think default no maps doesn't work. Let me see. Whoa. We are close to generating mesh in 2 minutes. 2 minutes and 15 seconds. Now we gotta do, oh, that was fast. So I guess I'm just gonna shut up and let this job finish. Okay, what was I gonna do? No apps, right? So no calculator doesn't work? Okay. It says like that a while ago and I Try to launch the GNOME system monitor and GNOME web browser. GNOME web browser works. And what else? GNOME shell works. GNOME Mayhaw works. GNOME menus blacklist. Power statistic works. I think these two won't work. This one and this one. No disk. Oh, it's not installed. So more or less, probably some of these won't work under a vanilla kernel built by AMD Threadripper. So if you need these apps to run, you gotta boot to the Ubuntu specific kernel. Let's go back to the thing, and wow, look at that image. Look at that model. I mean, it looks realistic. Wow. Now let's try to model. Oops. Let's try one more job here. Process, build texture. Ooh, that's big. 4096. Yep. Ortho photo. Okay. That is fast. Oh. Somehow it lagged and it's calculating again. Maybe it's how the layout of the texture map being placed on the plane on a UV coordinate. That's what's causing the process to take long, because that parameterization process is tedious. You gotta calculate the best optimum texture UV coordinates for the colors for, right? And let me see, 36, 37. Well, let's see if it. Nah, I'm not gonna measure that one. It's about 1 minute. Huh. Blending texture. Wow. There's a blend texture? Oh my god. 50 seconds. Let's check if 50 seconds, in 50 seconds, under it, if blending texture would finish. 25 seconds more. 20 seconds more. 20 seconds left. Wow. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, apparently it didn't finish at that 50-second mark, but still fast. And I'm just using the CPU. If I have OpenCL GPU enabled, it's much faster, I guess. Now I think blending texture, that's baking texture. Oh my god, it looks so neat. Wow. So guys, if you guys are an avid 3D modeler, the best way to prototype your model is doing it by clay and just photo scan the clay, which is good. I mean, this technology didn't exist in 5 years ago, and now it's all over the place. It's amazing how fast we progress. And now we have 142 seconds, about 2 minutes and 20 seconds that has elapsed to calculate the blending. That's it, guys. I've detailed the results for doing photo scan for this image right here, for the 65 image, into sparse point, which it has 54,405 points and 3,500,000 points for the dense cloud under medium setting quality, and a 3D model that has 700,000 faces, and the model has 4,096 pixel square, 4,096 by 4,096 pixel square resolution. And look at that, it's good. It's so amazing. Let's blow the model up. Wow. And it took about 2 minutes, 20 seconds, 27 minutes, and roughly 10 minutes. So that's about 39 minutes, 40 minutes in total to do a photo scan that has 65 images in at 8 megabyte size. I don't know what's the resolution of each images, but yeah, it shows right here. It's fast. It's really accurate too. I mean, look at the details on that feather. Wow, it captured the detail, the depth, the grooves of the feathers, of each individual feathers, and the hair, depth of the hair, the eyes, which is hard to capture. The mouth is really, it's good. It's a good scan. The fingers too. The hands, the feet. Most it's a good app or a program to use to convert your photo data set into 3D image. And I think I took a lot of time already, so here it is, guys, the result, and I hope you like it. Thanks. See you in the next one.